Okay, I don't need to go through this video because I may or may not have talked about this in a different video or not. I don't know. I want to make this kind of short, unlike my usual times. I've mentioned in this video, which is not even Veritasium's video, talking about the different ideas that I have for the type of stuff that you could do to confirm the speed of light in an area, in a specific scenario, and with all sorts of other things concerned. We don't have to think about the speed of light as being instantaneous between Earth and Mars as a concept. Because guess what? We can use relay stations to confirm that it took time to get to the second station and then from then on to the next station, and the variability between that and a full straight trip to Mars for light signal. And then also we can have that signal be sent through something like, I don't know, different mediums, have all sorts of different ideas about how to manipulate light, like with crystals, or with liquids, or with gases, whatever you want to think of. And the answer is, you can confirm the speed of light depending on the area. Now, what people talk about when it comes to time dilation is they believe, okay, look, there is ways that you can manipulate how fast light moves in a liquid or something. Where the fuck am I going? Where in the hell am I? I don't remember pressing any buttons. I'm disturbed.
matter relative to
This
antimatter.
video is scuffed.
And physicists have worked out internally consistent theories of physics in which the speed of light is different forwards and
So the idea that happened
you have this
was
really big, complicated mathematical equation, and you have on one side, you know what your starting point is, and you know what your ending point is, and in the middle, you could just say, oh, it's the answer half, and the rest of it's instantaneous. I think that's kind of what they're getting at. Remember, sometimes drawing like a little cloud that says magic on it says how you get there. This sounds about as silly as that.
signal takes 10 minutes to get there, and the reply takes 10 minutes to come back. But it's possible that our message took all 20 minutes to get there, and the reply came back instantaneously.
There's a reason why we can't make that assumption. It's because the stuff out there between Earth and Mars is the same stuff as everywhere else. The only way that the light would be able to move faster in one direction than another between Earth and Mars is because going to there versus going away is because the reason why we can't make that assumption. There is no physical abnormality of the space between Earth and Mars. Right? Once you get out a certain distance, once the electromagnetic field of the Earth is taken out of effect, like moving away from the sun, yes. There's an interesting thing about that, is that, oh no, he didn't even mention this in the video, but moving away from the sun, the signal could have a boost, and then on the way back towards the sun, it could be diminished. This is something that is the only thing that we could ever say is possible to affect the signal, because it's the only thing out there besides maybe radiation and whatever else that's coming out from outside the solar system, right? But then we would measure that, we'd know that, we would have reference of that, right? And again, signals moving, the thing about light is that it really doesn't like to interact with stuff, meaning unless you're in a substance, you're not going to feel any weird shenanigans with light, which is like, why is it happening out in space?
No way we could tell the difference between these two scenarios.
What about what
But
Mark
why would
said?
the speed of light be different? Well, it's possible that there is some preferred direction through space-time. Our universe has a lot of symmetries, but there is also some asymmetry. For example, why is there so much matter relative to antimatter?
There's a reason for that. In order for antimatter to form pairs and make bonds and do things, it originally has to be formed in the first place. Now, positive and negative stuff, virtual particles arrive and disappear all the time. We understand this. It's well documented that we have virtual particles all over the place. The thing about antimatter is that when it explodes, right, what is more likely to happen is you would get more dense amounts of regular matter, as all the rest of the antimatter would probably be lost in the explosion. Why would it not happen with antimatter? Well, the very reason is kind of simple. The functions of what make matter itself, protons and neutrons, with the up quark down quark difference, protons and neutrons are basically like an antiproton or an antineutrino. Although we measure them and we can say that there are individual things that are different to them and they are totally separate, it's possible that matter is, in some form, also antimatter. The positives and the negatives do their thing. It doesn't matter if it ever exists and then it was able to fuse. Some parts, which are positive, all attracted each other, right? The negative stuff combined in ways that made atoms with the neutrons and the electrons. But the idea of a positron, an antineutrino, and an antiproton, right? These things are less stable because basically the idea of antimatter is not just inverted matter of charge, it's inside out matter, meaning the protons and neutrons type parts of what antimatter would make into an atom are negative and repulsive, and they push away stuff. So what happens? The anti-electron, if it were to make in that atom, is constantly the one item that is positive that is pulling everything in. So what happens with the atomic particles within an anti-atom? Well, if it's negative, what would hold it together in the first place? There's no reason to assume that neutrons would be able to hold together with antiprotons. So how can you make atoms out of this stuff? How can you make molecules out of this stuff? And the fact that we were able to make that molecules were able to come about, such as oxygen and hydrogen bond pairs, O2 pairs, and carbon bonds, the very beginning stuff was able to fuse and do these things, and all the antimatter just wasn't able to cut it. All those negative parts never combined with neutrons or antineutrons, which really, what's an antineutron? There isn't one. There truly isn't one. If a neutron is neutral, how can you have a negative of that? And what difference would it make? The point is you have a negative function here, and the positive is the thing supposed to be orbiting that? No, it wouldn't happen. What would happen is you look at the forces of these bits, there is a certain amount of repulsion with an electron. The protons and the neutrons bind together with each other. The protons are basically binding together. The neutrons happen to be along for the ride because they fit into these packets. And then the electrons happen to want to be around because they aren't able to escape the protons' influence enough. They are able to get to different heights and levels and things, and they're able to fuse together, everything together to make more complex matter. Antimatter doesn't have stability in general. So the idea of questioning why isn't there antimatter in quantities similar to what we would see with regular matter? It fizzles out. There's no reason to question that. It could not exist among regular matter. It just doesn't. And the amount of matter that remained, like literally, in order to get a hydrogen bomb happening, you only need some hydrogen. Meaning, you could take out a lot of antimatter with hydrogen bombs. Beginning of the universe was basically like that, so why would you even make this question up? It's a ridiculous, it's ignoring the facts questions that are what I said in my comment, Veritasium, this video is gross. It's not insightful, it's not helpful, it's not supportive enough, it's vague enough to make people think that there's these possibilities, but also to mention, yeah, it's not even the situations where this becomes important are few and far between, and we can know the full speed of light in all sorts of scenarios.
And physicists have worked out internally consistent theories of physics in which the speed of light is different forwards and in reverse. The speed of light could vary by just a few percent, up to, at the extreme, going c/2 in one direction, and
the interesting thing is, why didn't you mention one such experiment, any such experiment, where we could say, like, you might have it in, I don't know, a link in your description. I don't know. I didn't look. But the idea is, if such a thing is possible, that in one direction light would be able to travel slower, and in another direction it could travel faster, then why would we say the speed of light is the absolute limit? Why are so many people so sure that the speed of light cannot be exceeded, even by a signal? There is a limit. There is a range and there's a limit. And then there's also the next thing, which could go faster. Regular light, visible spectrum light, has regular characteristics. We can find out what it is.
infinitely fast in the other direction.
Okay, so let me figure this out. So
the other thing is, light is moving in all directions at once from this light bulb towards everything in the room, until it hits stuff and ends up with shadows, diffraction, and like the speed of a shadow versus the speed of light itself. Silly question. Because it's the absence of light that makes a shadow. Never mind.
this is wacky to think about. I kind of don't believe you. I don't believe you that light is a different speed in one direction but in the other. But I know you well enough to know that you wouldn't call me and put a camera on me unless you knew you were right. And that does this thing change at all depending on what the light's going through? Like when light slows down in water, for instance, light slows down by like 25% in water. And that's why you can actually see that little blue Cherenkov glow that comes from having certain particles in a nuclear reactor going faster than light in water. Not faster than light in a vacuum. But I'm wondering
if water moves slowly, if the speed of light moves slowly in water, then Cherenkov radiation moving faster than light in water means it's more vivacious and energetic than light itself, because it's not light. It's a particle. There's a difference. It's a different kind of particle. Emitting light.
C/2 and then infinite would apply there, because then C/2 is different in this case. Well, not c over 2, it would be 0.75 c over 2, approximately, and then it fills the rest of the thing. I wonder if that also is taken into account.
Scares me about this.
I'm just gonna say you wouldn't say 0.75 c over 2. You would say you wouldn't say the c over 2 part. You would say a percentage of the speed of light. C over 2 is 50% the speed of light. So you would say it's 50% or it's 80%, 90%, blah, 69%, 420%. Who cares? But you wouldn't say the C over 2 part. You would just say the other part. 75% of the speed of light over 2 is more like 30% the speed of light. Just because you're cutting 70 in half. Half of 70 is 35.
That scares me.
Just say.
Now, you might think it is just simpler that light should travel at the same speed in all directions, but the truth is, that is a convention rather than an experimentally verified fact.
Yeah.
Einstein himself pointed this out in his famous 1905 paper on the
I'm
electrodynamics
not
of moving
saying
bodies.
it's totally
He spends the
false.
first couple of pages on the problem of
Like you said,
synchronizing
when it
clocks
comes
at
to
different
regards to
locations,
objects,
A and B.
substances,
And he says, there is no way that we can meaningfully compare the times they measure unless we establish by definition that the time required by light to travel from A to B equals the time it requires to travel from B to A. He's essentially defining that the speed of light in opposite directions is the same. And he puts, by definition, in italics to remind us that this is only a convention.
Basically, like a mathematician's.
The other thing that you could notice is that if you used a telescope, now hear me out, use a telescope on both ends are able to see simultaneously that their clock and the other person's clock are actually in synchronous at the same time. No? Not good enough? But you would be able to tell that as your clock is ticking, you see the other clock ticking. It takes a certain time for the light that you are noticing the thing happening, but at the same time, they're doing the same thing, making the same assumption, making the same measurement. This is why people talk about vacuums so much, and even in a vacuum, it's not the same.
Setting up assumptions that are believed to be true, like you're getting ready to define a proof or something. Okay.
It's known as the Einstein synchronization convention. So the idea that the speed of light is the same in opposite directions, as Einstein would later write, is neither a supposition nor a hypothesis about the physical nature of light,
Why
but a stipulation
didn't he make this
that
video?
I can make.
Why would he make this video? This is disturbing. Why would he make this video with Destin? Because although Destin is very good with measurements and things and doing all these maths and actual physics and stuff, physics and relativistic physics might not be his wheelhouse of like specialized expertise where he can tell you with certainty or like reference papers and all of these things. Maybe not. So what about other people? Who? Well, you would assume first mind comes to mind is besides Bill Nye, who's like been in all sorts of stuff, talked about all sorts of things. You could talk to someone like Numberphile and all of those people who do math stuff and think about how math works with things and such, and they wouldn't be any more helpful. Neil deGrasse Tyson Yeah, has some knowledge in things and stuff. He gets stuff wrong too. Everyone does. I get it wrong too, sometimes.
Of my own free will to arrive at a definition of simultaneity. That sounds a lot more subjective than how I think most people would imagine the speed of light is defined.
Okay.
Yeah.
Dude, this is hardcore.
Yeah, it's like
I've
even
never
the
thought
guy in
about
the
this.
beginning
I
was
didn't
like,
think about this before either.
you know
I always
what? This is
assumed that
just
when
an
we said
idea that I've
the speed of light is
imprinted on
c,
myself.
we meant the one-way speed of light.
I could
There's
be
no way to
fooled.
define the one-way speed of light. So the only thing we can really define is the two-way
Einstein,
speed of light.
good on
Just
you.
look at the way Einstein defines c. It's for the
Yeah,
round trip
okay,
from
yeah.
A to B and back. I don't know if you saw in your physics classes, but whenever there was a light clock, it would
Okay.
always bounce the light up and back. You would never see a light clock just bounce light one way.
Now, the thing about light in a train going at whatever speed is that when you bounce light up and back again, right, the speed of the train relative to the speed of light is a fraction that you would never be able to tell the difference. You just wouldn't. The amount, think about if you go 100, let's say the speed of light is whatever in 100 meters per second or whatever, 290 meters per second, right? And your train is going 100 meters per second. Well, what fraction is 290 million and just 100? Well, you take out the 100 and you say, well, it's 2 million, 2.9 million. And then you say, well, the 100 versus the 1, or better put, the standing still dude train, is a difference of 0.00000, right? There are at least 5 zeros in there, 1%. I may have put in 1 or 2 more. There may be a difference between the number of zeros, but the point is it's tiny. It's itty bitty. It's microscopic. It's an amount of light that you will not tell there is any difference whatsoever. Because trains, also, those trains physiologically are not doing anything to the light. The one thing you would notice, if you could notice any discrepancy, because you would have to do this experiment with, let's say you do this experiment, right? To do it correctly, you have to have the light of a very long straight track, and the light would have to be going down that track for a day or so. And then you might be able to tell that there has been a discrepancy. That is the amount that we notice with time dilation stuff. And that's because as you're moving, the target has moved now. The light is actually taking longer to get to where it needs to go. Multiply that by a certain factor of 100,000 or million, and you start noticing the difference in a couple days.
And this is why. The only thing we can be certain is constant for all inertial observers is the two-way speed of light. For over 100 years, scientists have tried to find a way around this.
What's interesting, at least from the engineering perspective, so a lot of things we look at in terms of physics, you look at, okay, what has been observed to be true and what kind of holds to be true for practical purpose. For instance, there's the whole gravity isn't a force.
It's like how we have no idea how planes work. We don't know how lift works. We assume that it's the shape of the wing and the stuff and the overhead and underhead, or the slope of the wing, and it pushes, making lift. One or the other, something, and planes fly anyway. Meaning we don't need to know the answer to get the correct result. We have a flying plane now. Shut up.
And
Bees
it's about
fly also.
gravity wells, relativity, gravity wells generated by things with mass. But when building a structure,
Yeah, like a black
you just
hole or
make the assumption of a force because that has a tendency to hold. But as far as the light thing, this one is almost making me wonder if we're really missing something here. And like there could be some engineering and design implications of one way being different than two way. Like we could make return trips faster. How much that would change things.
Measure the one-way speed of light by itself. Here is a paper published in the American Journal of Physics in 2009 that claims to measure the one-way speed of light. And here is the paper debunking this study, pointing out that these authors were actually measuring the two-way speed of light. But I'm imagining you might have some ideas for how to measure the one-way speed of light, so let's go through some of them. I mean, can't we just use a high-speed camera that shoots at 1 trillion frames a second so we can actually see light?
We already proved that light moves differently in a medium by having it move through the bottle. Look at what's happening to it in the bottle. This is awesome.
Have some ideas for how to measure the one-way speed of light, so let's go through some of them. I mean, can't we just use a high-speed camera?
Look at the light and how it's moving. Forget about this speed. We're going to really slow it down. Play.
That shoots at 1 trillion frames a second so we can actually see light.
You notice that the light was a bow shape, okay, as it was in that red section, right? And then you notice how that's a refraction index. Then, once it gets to the other section, it's more straight. It's also spread out. And other things are happening to the light, such as what's happening to it on the bottom. All of these things are calculatable.
Passing through an object? The problem is, you're not
measuring the two-way speed of light. You're measuring yeah. So we can see the difference of how light works through an object. But in most cases, we're not talking about through an object. We're talking about an atmosphere. We're talking about an energy barrier or something. Something we can notice.
Seeing the light pass through the object, you're also seeing it bounce back to the camera, measuring the two-way speed.
This is Survivor IO. This is our hero. Then, do you know what this is? This is Happy's all-new powerhouse title, Souls.
Pass through the object, you're also seeing it bounce back to the camera, measuring the two-way speed, not one-way.
Here you go. Get a spool of fiber optic cable. You know, I don't know, like 186,000 miles.
I like this guy.
And you could shine the light here, and you have the other end of the fiber here, and you could shine here, and then wait and see the delay. See if it's 1 second later over here.
The thing is, like, that fiber's going around and around and around, so it could be that when the light goes this way over the top of the loop, it goes slower, and then when it goes on the bottom, it goes faster. It all averages out in the fiber, and you're essentially getting lots of round trips.
Fiber is like a moving average. That's
so you're never getting a one-way.
You would have fiber optic cable in a straight line. That doesn't work either.
What if you center a synchronizing device between your two clocks and send out simultaneous pulses? Well, if the speed of light is the same in both directions, this perfectly synchronizes your clocks. But if the speed of light is...
The thing is, speed of light, again, you wouldn't use light pulses, you would use sound pulses because they could be recognized and they could be recorded, and they are slower than light, meaning the difference between the light and the sound can also be reconciled, and you'd be able to tell, does light move differently in one direction than another? And the sound is unaffected. It's a different, it moves differently, it functions differently, right?
Different in each direction, one of the clocks will be ahead of the other, and it will be ahead by just the right amount, so that when you measure the speed of light, you will find the value to be c, even though that was not the speed the light was traveling.
Yeah, that's kind of, I mean, it's kind of like the whole mean value. You're applying the mean value theorem to relativity. It's just going to be at the halfway. I mean, a whole bunch of weird stuff can happen.
And that's the reason. You mentioned the whole bunch of weird stuff. Well, at this point, we would have a bunch of different sensors that the light would go through, and also another light beam going beside it, separate from all the sensors. And we would have these two separate ideas happening at the same time, so that the light going one way or the other, whatever, we would be able to tell. It is no different throughout all of this system than it is throughout the entire length. And if it is different for all of the system, we can tell it's because of like the light traveling through the different sensors or whatever else, and their effect on it. We can do these calculations. We know
on either of
how.
these sides in between each individual clock. I buy that, Avon.
Is the same reason GPS
We can
synchronized
double the
clocks
amount of
won't work.
sensors, so we can
The whole
change the
GPS system
variables.
is based on the assumption that the speed of light is the same in all directions. If the speed of light is different in different directions, the light pulses from satellites will travel at different speeds, so the clocks won't be properly synced. By that I mean they will always measure c for the one-way speed of light.
A body out in space is moving at speed. So no matter where you're going out in space, you're still having to track an object that is moving through the solar system, through the galaxy, through the universe. So it's not just a simple, like, they're all stationary. They're never all stationary.
Whether it is or isn't.
Compensate.
How
That's a weird
about
way of
starting with
phrasing that.
synchronized clocks in the middle and moving them apart with equal and opposite speeds?
I like this idea.
That way the
That's
time
cool.
dilation for each clock will be the same and they'll still be synchronized when they reach the endpoints. But again, this only works if the speed of light in each direction is the same. If the speed of light depends on direction, then so does time dilation.
Yeah, at this point, you might as well take, I don't know, the same light and put it on like 4 clocks and have them move, or however many, and have them all move in slightly different directions. And yeah, I can see the problem of starting with an underlying assumption that you're not sure is accurate. Yeah, it's a chicken and egg yet again.
I think you could move the clocks really, really slowly so that time dilation is negligible.
If you want
But
to
if the speed
question
of
a
light is
single
different
measurement,
in
that's
different
easy.
directions, you can't
Once
just
you have
use the standard
multiple
formula to
repeatable
calculate what that
systems,
time dilation would be. I mean, it could be a lot worse than you
it's
think.
harder to get
So
it wrong.
the reality is we're stuck. We need synchronized clocks to measure the one-way speed of light, but we need to know the one-way speed of
That
light in
synchronized
order
clock.
to synchronize our clocks. Now, this might sound like just an academic concern, so I want to go through an example to illustrate just how
This seems
differently
bigger.
the universe works if the speed of light is not the same in all directions. So let's say on Mars, Mark is trying to synchronize his clock with the Earth. At noon, Mission Control sends out a message that says, "This signal was sent at exactly 12 o'clock." When Mark receives this message, he uses the Einstein synchronization convention to set his clock. He knows the round-trip time delay is 20 minutes, so he assumes the signal must have taken 10 minutes to reach him. He programs his clock to 12:10 p.m. and sends a return message. This reply sent at 12:10. The message is received on Earth at 12:20 p.m., so both parties know the synchronization was successful. When the clock reads 12:20 on Earth, it simultaneously reads 12:20 on Mars. But now consider what happens if the speed of light is not the same in both directions.
This is a bit off topic, but you know how there are time zones on Earth?
The thing is, if you had a consistent stream of time, whereas all of the signals that you are sending are continuous, as in a video constant recording of said clock doing its thing with the ticking and everything and such, you would then be able to say that there is a correlation between the ticking on one side. We're noticing that your video has regular, it is all working at the same rate. Every time that signal is sent in one direction, it's all sent fluidly, with a delay, but fluidly. Him sending the signal back, the signal and the video and everything else would be sent fluidly. Or you would notice these giant jumps in time. You would notice that there is a kind of gap delay between Mars and Earth. You could compensate for it. You would be able to be aware of it happening. As long as the signal sender from Mars is reliable.
What's the implication of that being on Mars? Are they just gonna, we colonize Mars, they're gonna...
Worried about catching up in Arknights? No stress. We're showering newcomers with gifts.
Mars, are they just gonna, we colonize Mars, they're gonna cut up the time zones on Mars to have it somewhat reflect Earth? Because it makes sense for Mars for it to be the same time zone as Houston, for instance, for that's what Mission Control's at, but I'm just wondering about that. Also, how much jet lag
the
you
way
would
that
get after
Mars
you fly to
moves
Mars.
relative
Probably a lot.
to
Let's say it is c/2 from Earth to Mars, and then instantaneous from Mars back to Earth. No one knows this, of course, so they continue to use the Einstein convention. The message is sent from Earth, but now it takes a full 20 minutes to reach Mars. But Mark doesn't know this, and as before, he assumes the signal took 10 minutes to reach him, so he sets his clock to 12:10.
Again, this wouldn't happen with a constant stream of video, because a constant stream of video would end up with gigantic gaps of absolutely no video, and then whatever else, and you'd be able to tell. You could tell. There's no way you wouldn't be able to tell. Stop it.
p.m., even though on Earth it is now 12:20. Mark then sends this reply sent at 12:10 p.m., which is
a single
instantaneously received on Earth at 12:20 Earth time. The experience for the two communicators is the same.
You're ignoring some facts.
The same messages were received with the same local time delays, but their clocks are out of sync by 10 minutes. What they think is the same moment for the other observer actually isn't. And there is no way they can ever recognize or correct this error. Imagine if someone on Earth immediately responded, "How long did this message take to reach you?"
There's no way to correct this error with a singular
the message
pulse.
would take 20 minutes to reach Mars.
That's why you send
due to the
many
clocks
pulses.
being out of sync, it would arrive at 12:30 Mars time, so Mark would reply 10 minutes, a message that would instantaneously reach the Earth at 12:40 Earth time.
Yes.
The space-time diagram shows how there is...
That's a brilliant illustration of this, and very simple, but I never... Man, before this video, I didn't even realize this was a...
Space-time diagrams make me
in what
kind
you
of annoyed.
consider to be the same moment at two different locations, and in how you define the one-way speed of light. Einstein chose the convention where the one-way speed of light is always the same, but from an experimental perspective, any other convention is just as valid, up to and including one where the speed of light is c/2 one way.
It's not that it's impossible, it's that you can do tests to make sure.
It's interesting to think about what each observer is seeing when they look at the other. Mark would be seeing the Earth as it was 20 minutes ago, but Earth is seeing Mars in real time, exactly as it is right now. And this effect wouldn't stop at Mars.
Exactly. 20 minutes ago, and you seeing it as it is right now. You're wondering to yourself, well, if it's instantaneous, then you're getting lots more information than you are sending. If you send a pulse every 20 minutes and you're getting pulses instantaneously, guess what? Their video is going to be crystal clear, and your video hasn't even booted up yet. Hard to get that wrong.
Look beyond it, and you could see stars
Go to, like, the
hundreds of
Hubble
light years
horizon.
away.
Yeah.
Not as they looked centuries ago, but exactly as they are right this instant. One of the things is, you only know about that light.
Light moving from galaxies could be and is warped by the Lorentz factor, the going through the atmosphere of the other galaxies that it's passing through. So you can have stuff like galaxies that end up at all sorts of different points with these pictures that is like it shows up here, it shows up there, it shows up there, but that's actually an after image light that bounces off, goes through like a prism effect, turns into a different image somewhere else. But it all came from one spot behind this galaxy over here, and we can find that. And we have.
When it reaches you, and you don't know anything about what journey it took to get to you. You just see it, and it's there, so like it's instantaneous. So an instantaneous interpretation of that light is just as good as one where it takes C to reach us.
This is breaking my brain. Yeah. I mean,
sorry,
it's kind of unknowable, isn't it?
It is unknowable. That's the whole point of the video. Is to say, we've all agreed, and this is based on something Einstein wrote in 1905, we've all agreed to just say, it's C in every direction. But
Interesting that we haven't really questioned it that much from 1905. I mean, yeah, there's been other attempts to measure it, but it's interesting. I guess the only way to find out is if we could somehow do something where we would go faster than light. Then again, to the observer,
this is again gaslighting and
other than seeing the real,
forcing the idea. This is happening at real time. Present the idea, give the person the time to analyze and think about the situation. They'll be like, well, the scenarios you gave, I've spent like a month on it. I can tell you for certain you've forgotten about this, this, and this. You can't make that assumption. You can't make that results that are conclusive at all, because it's all happening as like, oh, I experienced this thought. I have to give a response immediately. It's going to be used as a clip in a video that's short.
Equivalent of Cherenkov radiation.
Not a lot of time.
I still wonder if it would have. This shouldn't affect. If you're just talking about like the transmission of, since we're talking communications, that wouldn't be a thing, since the electronics would travel a lot faster than, say, light would travel close.
I'm disappointed. Everyone knows electronics travel a fraction of the speed of light. There's a reason fiber optic cables are better. Right? Actual electronics is very similar to the speed of light.
To see, or a lot faster than the speed of light.
Definitely not faster.
In water. So the whole 0.75 C over 2, I don't think would be a thing, unless I'm missing something.
Truth is, the physics works the same, whether it's C or the C over 2 and instantaneous, or anything in between. As long as the round trip works out to be C, none of physics breaks.
The only saving grace is that anything in between is possible, but you can measure that, you can tell where it is, you can tell what medium it went through to make that potential difference and stuff.
And that's the crazy thing. So if we can never measure the one-way speed of light...
Then again, because we're the ones who define physics, part of it is maybe just our vision of what physics is could be different. Just like when, again, going back to the whole gravity not being a force example, because Newton didn't know about gravity wells, but you knew about mass and acceleration due to gravity. So I think we could just be missing another piece to the puzzle.
And if it makes no difference.
Interesting thing. Yeah, it's acceleration due to a mass that's moving at a certain speed. Once you start moving at faster and faster speed, you experience more and more force of other objects, heavier or otherwise, pulling you back. You're like, wait, what if I have someone pushed at a certain speed in a vacuum chamber, right? But they're in a spacesuit, so they're fine. Put them in a vacuum chamber, in a spacesuit, have them be like suspended from like set of ropes or whatever. So the ship is moving forward and they are projected forward. Is it possible that you can become self-propelled enough that you don't experience the force of moving through space? And the answer to that is it's a ridiculous notion.
To any of the laws of physics, then what's the point in even talking about it? Well, that is certainly one valid perspective in a debate that has been ongoing since 1905. Some physicists appeal to Occam's razor. Isn't it just simpler if light travels at the same speed in all directions? Most working physicists just accept the convention.
It's not just that it's simpler, it's that we can make these measurements, and we have. And so it is known. And you're shedding doubt on something that is verified.
And move on with their lives. But I think it's important to point out that it is just a convention, not an empirically verified fact. Personally, I find it fascinating that this is something about the universe that is hidden from us. Sure, the round-trip speed of light is c, but does the one-way speed even have a well-defined value? And if it doesn't, what does that mean for the concept of simultaneity? When is right now on Mars? Does it even make sense to talk about things happening at the same time if they're separated by distance? Maybe this is an odd quirk of the universe and there's no good reason for it. Or maybe when physics takes the next paradigm,
don't worry, I have more cheese balls.
Our inability to measure the one-way speed of light
put them into
will
this
be
container so I
the
don't
obvious clue to the way general relativity, quantum mechanics, space, and time are all connected. And we'll wonder why we didn't see it before.
I don't know. I'm not a physicist. That's fascinating and not something I ever really thought very much about. I think it would be cool. It's kind of an idea that we could be on the... It could be something that could either click together or something that could help us with another discovery later on in terms of physics. But yeah, my head's still kind of spinning after this one. But that's an interesting thought experiment he did about.
Yeah. Half-baked thought. It's not even that. It's that the statement is we have never. It is impossible. And these other things. Just because you didn't think of the ways that it could happen doesn't mean that that's not how it happened. Or how it can be done to make these experiments possible. So I submit to you that, Derek, you failed. And good reaction, good ideas, and how, yeah, there's a bit of mystical ideas involved in all of this. It's kind of a little bit overreacting and over simplifying or overthinking about things, and good job on you for your reaction. also fun. And I'm sorry, but hey Derek, remember that car that moved faster than the wind? That same physics is the reason why we can move faster than light. Think about that. And yeah, anyone else can think about that and tell me in the comments what you think about that and all of that. Yeah, we can move faster than light. Can you hold yourself together while moving faster than light? And the answer to that is usually no. Once you start moving faster than light, you start disintegrating. So, but can you? Can it be done at all? The answer is, if you could hold yourself together, you could move faster than the speed of light. No problem. Yeah, self-propulsion can move faster than regular light that doesn't have propulsion, or has a limit to the amount of exertion that it can exert. Also, if you accelerate the medium that the light is going through, if it's able to slow down in certain mediums, speed that medium up, and suddenly the light is moving faster. You would need to have a water jet stream that is solid and able to, like not water, but a liquid jet stream that is able to be solid. It's able to move at relativistic speeds and have light move in that object. And yeah, it'll move faster in one way than it will the other, because it is actually affected by the object, especially if it's electromagnetic involved. Something, like tiny bits of magnetic or something. I don't know how you do it. There's ways to do it. We just haven't done it yet. I'll get to that later. If you found this interesting, check out the Science Me playlist where I talk about all sorts of things science, including relativistic physics and biology, chemistry, and whatnot. I talk about all sorts of stuff. And I am not... Like they say, without the gobbledygook, I don't put in mysticism. I don't put in magical ideas. I say it as it is. You put in a relay state setup, and you're going to have an accurate light speed setup, and you're also going to have repeated experiments, more repeated and more sure results, depending on where you're looking at. Time doesn't dilate. Moving on. It doesn't. The satellite's clocks are affected by stuff moving at certain speeds. It affects the atomic particle that you're measuring with the light. I think it's borium and beryllium, whatever. Boron, it doesn't matter. It starts with B. They use a particle, they're measuring its vibrations. It's a certain number, it's in the billions, and we can tell from that its massive number of vibrations. We tell that number and we know how much time has gone by measuring at extreme rates per second, right? So that's cool. But it doesn't mean there can't be flaws in those systems. Toodles.